Welcome back to Learning with Merit. Today we are going to cover basic computer networking, all these skills that you might need and understandings that you need to have in order to operate a home network, for instance, and all of the devices on it. We're going to cover several things in this video. We're going to talk about LANs, which stands for Local Area Networks. We're specifically going to focus on those. There will be some more wide area topics, but we're going to focus on local stuff. We're going to talk about connecting devices together. That's going to be Ethernet cables, optical cables, how we use wireless networking. We're going to talk about switches and routers, modems, optical network terminals, internet service providers, proxies and VPNs. These are all different ways that we connect these devices together to form the networks. Then we're going to talk about some basic networking protocols like the IP address, DHCP, which is Dynamic Host Configuration Protocol, and some things that go with that like MAC addresses, IP addresses, network address translation. Then we will talk about, as we go in here, some basic networking commands that we can use to learn about some things. And then we will do an overview of the OSI and TCP IP models, which are how we break up sort of the traffic and things that go across the internet. So without further ado, let's go ahead and get started. So if we start here, we know that the LAN stands for Local Area Network. Now, a local area network can vary in size, but it is typically a local network. So this could be for a home, a school, or a business, and this is going to be the way that we're talking about it today, your home network. So let's think about some of the devices that we may have on a home network. Here I have some networking icons that I've sort of created here. Some of them, all of them I've gotten off the internet in one way or another. We might have a desktop computer, we might have a laptop, a tablet, a phone. And here we have some of the networking devices that we're going to need. We'll talk about later. We may also have things like gaming devices like a PS5, Xbox, Nintendo Switch. And then I just added this thing right here, other smart appliances, because there are a lot of different things out there we call the Internet of Things, and they may show up as well. So I'm going to copy a few of these and move them over here to our network. So let's start with simple stuff. Let's say that on my network I have a phone. That's my phone. I may have a tablet for me. I may have a laptop, and I may have a desktop. And let's say that I wanted to connect all of these things together. Well, the first thing we need to think about is how would I connect them together? Well, there are two ways. There is wired and wireless options, and they're usually going to go together. So there are two types of wires. Wired connections. In my wired connections, we have Ethernet cables, which are copper cables, and then we have something called optical cables. If we go over here and we go to Google real quick and we look up, let's see, we can look up Ethernet cables. Let's see what we can find in images. So these are all Ethernet cables, and you've probably even seen one before. Although most things that we use these days are now wireless. What you're going to see most of the time is something that is wireless. We also have optical cable, or fiber optic cable. Now, optical just has to do with light, right? So you may see some different cables, but you've probably seen examples of these little tiny fibers that look like light. Maybe something like this, and here's an excellent example right here of some optical cables that you may deal with. Now, optical cable is much faster than Ethernet cable, and the reason is it uses light. So all of the transmissions, everything that goes through it, travels at close to the speed of light, which is extremely fast. Whereas electrical signals cannot travel quite as fast over the copper wires. It also allows you to get much more data through, and of course a very fast way. So optical cables are what most people are using nowadays as much as they can. Now, that doesn't mean that you won't see Ethernet cables. Ethernet cables are typically used within the house. And there's probably an Ethernet cable in your house, even if you don't realize it, between a certain device called a router and either your modem or what we call an ONT, which is an optical network translator. Anyway, we're going to get to those. But those are our wired connections. Now, wireless networking. Let's talk a little bit about that. Wireless networking deals with something we call Wi-Fi. Now, a very interesting thing about Wi-Fi. So, Wi-Fi, you may think actually stands for something, and for a long time there has been arguments over whether or not it stood for wireless fidelity. But actually, it's just a marketing phrase by the people who developed the IEEE standards and used it to market wireless networking to people. So it sounds similar to something called hi-fi, which for a long time was used as a phrase for high fidelity, which basically means that the connection would continue. And it tends to not drop out or do anything like that. So Wi-Fi doesn't actually stand for anything, but it does represent what we call the IEEE 802.11 standard, which is the standards that everyone agrees to use for wireless communication. Now, wireless communication is actually just radio waves, very similar to the radio waves that are in a vehicle, and they range from 1 hertz to 3,000 gigahertz, which is a very large range. Now, what hertz is it's a unit of frequency, or what we call cycles per second. You can think of this like a circle. How many times you go around the circle, right, every second. And giga is a very large value, okay? And it's 10 to the 9th power. So 1 with 9 zeros behind it would be a giga. So if we look at this, the two most common frequencies used, and these are important for your home network, is we have 2.4 gigahertz and we have 5 gigahertz. Now our main difference is that 2.4 gigahertz are longer range and they support older devices, but it tends to be a slower network connection. 5 gigahertz is much faster, but it has a smaller coverage area and has a little bit of trouble going through solid objects. So whenever we determine what type of network we want, or if we want sort of a hybrid network where we have both of these frequencies, it's important for us to determine, like, what is our use case? What are we using it for? Are we, trying to connect from long ways away, and we want to make sure we have a good connection, even if it's slower, or are we trying to get as much speed as possible, and we're fairly close to the thing that's transmitting the wireless connection? So, anyway, wireless networking. Now, it's important we know it's the 802.11 standard, which is actually what Wi-Fi is. It's just a standard of radio communication protocols that are based on basically just what people agreed to do. And then nowadays we have 2.4 gigahertz and 5 gigahertz frequencies that we use, and that is the way that we communicate with this. So let's talk about these devices. I'm going to go ahead and get this out of the way. Now we have 4 devices, and I want to be able to connect them together. And so we are presented with an issue. How do we do that? We need a way to know what device is what, and what information is going where, and all sorts of things. So used to what we would use, and we still use these quite a bit, is something called a switch. And this is a very small switch, like one you might see in your home. It is possible to have much larger switches, and a lot of places that use switches a lot will have very big switches because they're connecting a lot of devices. So I'm going to go ahead and copy this and move this over. Now this switch would allow me via cables, assuming each one of these has an Ethernet port or some sort of optical port, it would allow me to connect all of these devices together. So we're going to take this right here and we're going to draw a line from all of these devices up here to this switch. And that way we know they all connect together. So now what I have is I sort of have a tiny little network here. And that means that all of my devices are connected via a cable to this switch. Now the switch keeps track of everything and allows me to communicate. Now the problem is, how do I keep all of this stuff together? How do I know that the desktop is the desktop, the laptop is the laptop, and so on and so forth? How do I know which device is which and where to send the information? You know, if I'm the phone here and I want to send it to the laptop, how do we know that the laptop is the laptop? Well, now we need to talk about something called a MAC address. So a MAC address. A MAC address, or media access control, is a unique identifier that's assigned to what we call the NIC, or network interface controller, and is always a set of 6 hexadecimal numbers. So each one of these devices, it'll look something like this. And each one of these devices will have their own MAC address. So if we were saying that we started from the very beginning, these are the first devices ever made, and each one of them has a network interface card, which allows us to connect to the network, we could say that this is all zeros 1, this is all zeros 2, all zeros 3, and all zeros 4. And these are the MAC addresses for the first 4 devices ever in existence here in our network. So obviously they are not these numbers for the devices on your network, but now we have a way to say what device is what, and the computer can understand it. And these MAC addresses are burned into the network interface controller. So the point of this is, this desktop will always be this MAC address. This laptop will always be this MAC address. This tablet will always be that MAC address. And they are a set of hexadecimal numbers. And we've actually talked about hexadecimal numbers before. So you know, these are 6 hexadecimal numbers for each of these. And this provides us a very large set of possible numbers that we could go through to have a very wide range of MAC addresses. Now that's pretty simple for our network switch. We want to connect all that stuff together, and we can do it via cables, and now we have an address for everything, and we know where to send the data and how to keep track of it, and we're good to go. But now things get a little bit more complicated as we work our way out. Now let's say that we want to start doing the internet, right? Now it's not just a little, simple local network. Suddenly we need the ability to communicate with other networks other than our own. Now we need something more than just a network switch. Now we need something called a router. So what a router does is quite a few things, especially nowadays. But the router will often contain its own little switch. And so these devices, the network switch and the router, can sometimes be the same device because they have both pieces connected in there. But we're going to separate them out just so we understand the different aspects here. So if I take this switch, we would connect the router to the switch like that. So now what we have is we have the switch that keeps track of all the devices on your network. Then they all have MAC addresses. And the router is going to allow us to eventually connect out to the internet. But the router is going to do some new interesting things. And a lot of stuff is going to come flying at us now as we deal with the router. So let's talk about what the router does. First of all, if we have a wireless connection, so let's say that none of these are wired connections. We have a wireless network, and the switch is a part of the router. These little antennae here, however you want to say it, are going to send out the wireless signal. Now, how do these devices know to connect? Well, we have something called an SSID. So let's throw this on here. An SSID, also known as a service set identifier. In other words, you can think of this as the name of your network. So the router has some sort of SSID with it. And let's add this over here. So like that, we'll say SSID, and this is the network name. So whatever the name of your network is, that's the SSID of the network. We're going to make it a little bit smaller so we have enough room to add things. Now the service set identifier allows all of these devices down here to connect to the network. And so this network could be called, I don't know, let's call it my Wi-Fi, something like that. So now the network's name is my Wi-Fi, and this phone, tablet, laptop, all of these can find my Wi-Fi and connect to it. And we can call our network whatever we want to. It doesn't really matter. Now you may ask yourself, why do we need this router? Well, the router is going to connect us out to the internet. So let's go find a little network icon here. This is going to be our cloud to represent the big wide world of the internet. And we're going to take this right here and we're going to connect it. So we're going to grab this. We're going to connect our little line over here to the internet. Oops. Grab a text box. Boom. This is the internet. So the router sits between the internet and our little network over here. And it allows us to communicate back and forth. Now we need something in order to communicate with the internet, and it is called an IP address. So let's look at what an IP address is. So internet protocol address, IP protocol, is what we use in order to give each device its own address. Right? And basically there are two versions of this. There are IP version 4 and IP version 6, and I'll explain the difference between those in just a second. But this is a unique string of characters used to identify each device on the network. So your router has an IP address, and each one of these devices will have an IP address. And that's what the internet protocol is for, is so we can identify all of these devices. And you can think of it like this. You have a home address. Well, we need the same thing for all of these devices. Each of them needs an address. And just like you have a street name and you have an actual specific address just for you, all of these will have sort of street names and an address just for them. So now, internet protocol addresses. Let's move this over here for just a second, and let's talk about IP version 4 and IP version 6. So IP version 4. This is the one that you may have seen before and used before. So IP version 4 is a set of 4 8-bit decimal numbers separated by a period, and that gives us 2 to the 32nd power possible addresses, and that's a very, very large number. And believe it or not, we're actually running out, which is why IP version 6 has started to exist. So IP version 6 is a little bit different. Instead of using decimal numbers, it uses 8 16-bit hexadecimal numbers. And if you remember bits are zeros and ones. And we have 16 of those. Okay, so we have 8 16-bit hexadecimal numbers separated by colons. And that gives us 2 to the 128th power possible addresses, which is very, very, very large. It's a massive number of possible addresses. And so basically we use these in conjunction now. So if we come down here, and we're going to give each of these an IP version 4 and an IP version 6 address. And we're going to simplify things. So our first thing is the MAC address. So let's add, right down here, our IPv4. So we'll do IPv4. And most home networks are going to look like this, and so there's a reason why I'm using these numbers. And let's give you, I don't know, let's give you 100. So first one right there, we're going to give IP version 4. Let's make sure we know this is the MAC address. We're going to make all of these a little smaller. So you'll see that I've added an IP version 4 and an IP version 6 address for all of these devices. So now, and you'll notice even something more strange, there's a bunch of extra colons in each of these, and the reason I did that is to help shorten them up. So basically, between each of these colons, you'd have a set of 4 zeros, and that is why you don't see them. I didn't omit the leading zeros on this on purpose, but there is a shorthand for IP version 6, and you will see some of it used later on. But the idea is, you'll notice that's hexadecimal, that's hexadecimal, that's hexadecimal, that's hexadecimal, right? All of this in IP version 6 is hexadecimal. In IP version 4, these are decimal numbers, each of them between 0 and 255. You'll notice I use some very similar numbers on all of them, but of course they each have a unique address. So now we have a MAC address, we have an IP version 4 address, and we have an IP version 6 address. And that is very good for us. Now we can do lots of different things. We have an address for everything, and it's making it so that we can communicate. Now we need to talk about something called the public versus private IP addresses. So the way you can think of it is the public IP address, the one that everyone else sees, is at your router. Your router contains the public IP address. And then the private IP addresses, which are what we'd have down here, those are for the private devices on the network. So outside of your network, no one sees the private IP addresses. They don't exist anywhere except on your network, right? And then in the router, right, the router's public IP address is what the internet sees. Now we have an interesting protocol that goes along with this, and that protocol is called NAT, or Network Address Translation. And what it does is it translates back and forth from the public IP to the private IP addresses. So let's say the phone wants to connect out to the internet and get some information. It sends its information through the switch, through the router. The router is going to send that request out, right? And then it keeps track of what device on the private network is supposed to receive that traffic. And so it sends it out, and then when it gets a response, it brings it back all the way through here and finds that private IP here. But your public IP may be a much different number. And so if you look up what's my public IP, you'll see that it's shared between all of these devices. Each one of these devices on the same network has the same public IP address, but they do not have the same private IP address. So the router has to have a way of finding each of these devices. So they have a private IP, which is what we're looking at here. The public IP is on the router, and that's very important. That's what everyone else sees. It also means that in a lot of ways, the public IP address can be used to track you. Some more things about IP addresses that can be important. There is a special reserved address, and this is on every device. 127.0.0.1 as an IP version 4 address is what we call a loopback address. So if I wanted to send a request to myself, right, like this laptop right here, maybe the laptop wants to send a request back to itself, it could use this IP address to do so. And that's why we call it a loopback address. It comes back to you. Now the range of private IP addresses that we use for home is right here. So that's the reason why you see every one of the ones that I picked uses 192.168 dot something, right? And so these are reserved IP addresses that are private IP addresses, and you will see them reused in pretty much every home network anywhere, right? You're going to see that 192.168.0.100. Now, this is just something I picked. It could be different. You totally could get a different IP address, but most places are going to use that 192.168 address. It's going to be rare that you see anything different. Now, the router needs its own IP address as well because it's a part of the same network as these other devices. It will also need its own MAC address. So I'm going to copy these right here and move it up here and give it its own MAC address too. Let's just call this 0 for this one up here. I'll leave that one 0 too. Now, the IP address is usually very special. So we have reserved numbers for the IP version 4 address, and this is the private IP version 4 address that we're dealing with here. Now, you may have a public one. You will also have a public IP version 4 address, which could be any kind of number, really. There's a large range of public IP addresses, and we'll come up with one for this in just a minute. We'll actually look up our public IP address. So there are ranges of private IP addresses. So we know that this has its own special IP address and allows all of these devices to connect to it. It also has a public IP address, which might be like 104.125.30.92, something like that. It could be a number like that. And this is how things from the internet are going to come back and access the router. And then the NAT forwarding, it's going to translate this IP address here into one of these private IP addresses on your local network. Now, you may be sitting there thinking, wow, this is a lot of stuff to keep track of, and it is a lot of stuff to keep track of. How do each of these devices get an IP address? Like, I connect to a network. How do these devices get their IP addresses? That's an excellent question. And we use a certain protocol for that. This one is called the DHCP protocol, or Dynamic Host Configuration Protocol. Your router is the thing that does this. So your router will communicate with these new devices as they connect, and your router will assign an IP address for these devices. And it keeps track of all the other devices on the network and their IP addresses, and it maps those IP addresses to MAC addresses, and it keeps track of all of that. And so then what will happen is once a new device comes on, it will say, all right, here are the addresses we already have. Here is your new address. And we call this the Dynamic Host Configuration Protocol. And that allows us to have new devices connect to the network, no problem. So a few more things we need to keep track of here. There's actually a device, depending on what type of network you have, that sits between the router and the actual internet. So we're going to delete that right there. Come back over here to our network icons. It's going to be one of these. If you have fiber optic cable, it's going to look like this, and it's called an optical network terminal. Make this a little bit smaller. And we're going to add a text box. Call this optical network terminal, or ONT. We'll set it right there. You may also, so this is if you have fiber. I even stick that on there. This is a fiber network thing. If you don't have fiber and you have copper, you have something called a modem. Make this smaller. I'm going to stick that right there. So if you have copper internet, so it comes in over copper, you'll have a modem or a modulator demodulator. And this actually, it's possible that you have the modem, the router, and the switch all in one device if you have certain different types of internet. But anyway, so the modem is going to translate digital and analog signals back and forth. So that they can be transmitted over the line. And then we have the optical network terminal, which is designed for fiber optic cable, which converts the light signals into electrical signals that can now be read. So one of these two you will have, and I'm just going to connect it to both of them here so that we understand it's, you know, sort of one or the other. Right? So you can connect to either one of those, and one of those will connect you out to the actual internet, just like that. So, fairly simple. The optical network terminal is for fiber, the demodulator or modem is for copper wires, and then we have our routers and all of our little devices on the internet here. Of course, we have our network switch, which I can move over just a little bit more. Set that there. We have our service set identifier, which is the name of our network. We have addresses for everything. We know that our public IP address goes with the router, and the private IP address goes with the device. All right, so we got a lot going on here, and this is just a very simple network. So I've zoomed in here a little bit, and let's talk about the internet side of things. So if we look at the internet side of things here, we've got a couple things that are important. One, the internet is provided by an ISP, or Internet Service Provider. This is who you pay for your internet, right? So they provide all the connections and everything you need in order to connect out to the internet. Now, if you want to send a signal, so like I want to go to Google, I type in google.com, and something very interesting happens, right? I've typed in www.google.com, but there's actually an IP address for google.com. Now, we call this, okay, we call this right here the URL, or Uniform Resource Locator. But the idea is that I actually have to have an IP address to get to Google. I have to have a way to get there. So we need a way of translating from the URLs to those IP addresses. And we need to sort of have it all hidden so that we don't see it. This is something right here called DNS. The Domain Name System, or Domain Name Service. I've seen it written before as well. But the domain name system is what translates those web URLs into IP addresses. So this is how we look up the address of a computer where a website is located. All right, so maybe I'm here, let's come back over here. Maybe I'm here on my phone and I want to connect out to Google, and so I type in www.google.com, and it sends that information through the switch, through the router, through the optical network terminal out to the internet via my internet service provider, and then it's got to go somewhere, right, to look that up. Well, where it can go, and there are a lot of different places, but usually your internet service provider will provide a DNS server. So the DNS server is where we actually look up and translate everything. Now there's a public one, public DNS server. There are some that you can find, but Google's the most common one here, and they have two addresses here. So 8.8.8.8 and 8.8.8 or 8.8.4.4, right? These are two public IP address servers for Google that you can use, and you could even set it up for your router to use one of Google's DNS servers. And so what happens is you always connect out to this DNS server, and it translates from the URL to the actual website's IP address and then allows you to go there. So all in all, not too crazy on what that does. Now we have two other things we want to talk about here that have to do with accessing the internet. We have a proxy and we have a VPN. And I'm not going to go too deep into what these are, but basically what a proxy is, it's a system, server, or router that acts like a middleman between users and the internet. So one of the things that will happen, and I'm not going to show you because it's bad to leak this sort of stuff on the internet, but if I went and looked up my IP address right now, it would very easily show you very close to where I live. And that can be an issue for privacy sometimes. And so what you could do is you could use a proxy, and you could send all of your traffic through another device that is in another location, and it hides your public IP address because now you're using the public IP address of that device. Right, so whatever router it's connected to, that's the public IP address that's going to be showing, okay, whenever you use a proxy. Now, a more advanced form of the proxy here and is called a VPN, or a virtual private network. And you will probably see this, depending on what kind of job you do in your life, you will probably have to use a VPN at some point if you haven't already. A VPN allows us to connect securely using encryption to a network outside of our own. And so, for example, if a teacher wanted to put in grades in the gradebook, but they wanted to do it from home, they would have to use a VPN to connect to the state's network, and then that allows them to have a secure connection between their home network and the state's network, and that would allow them to put in grades while they were at home without the fear of that information being leaked or something like that. Now, there's always ways to break things, always ways to get into stuff, but that's basically what a virtual private network is for. And that's the reason why you see so many people push it for privacy, is it incorporates the concept of a proxy, where you use another device to channel your traffic, and it sort of provides a guard to your IP address. But not only that, when you use a VPN, okay, while the provider of the VPN could technically see your traffic, that is the downside to it, it does encrypt your traffic from everyone else between you and the VPN, and then the VPN has a proxy that allows you to send out that information, and it hides your IP address and things like that. So there are very good reasons to have both of these, especially when you're talking about privacy and security while on the internet. Now, let's move on. Now that we've got that out of the way, let's actually take a look at the application of some of this stuff. So I recognize this is just us drawing a diagram of a very simple network that's doing all these different things, but I actually want to look at the application of this information. So let's open up something called the command prompt. And the command prompt is going to allow us to communicate with our computer here and do some different things. So go ahead for me. You're going to hit the Windows key or the super key, but it should say Windows or have the Windows icon on it. You're going to hit Windows R. And you should see this little run command prompt up over here. Now what you're going to do is you're going to type in CMD, just like that, and hit enter. And you should see a little window like this pop up. Now I'm going to use something a little bit different because I'd like to make the image bigger and allow you to see it and that sort of thing, but this is what you're going to use. So I'm going to use a little Windows terminal tool here, and open up a command prompt. Make it a little bit bigger. All right, now we can do a lot of different things with this, but the first command that we are going to look at is called, let's see, basic networking commands, ipconfig. So ipconfig. This is a very useful tool if you want to see some information about your network. So if I ipconfig here, and there's a lot of information, it'd be kind of hard to read, but what you can recognize is some stuff like this. There's IP version 6 address, there's some IP addresses, some things that look like that, and then something called the default gateway, which if you remember, I wrote that down right here. The default gateway is your router's private IP address. So while mine has a lot of different things on here, yours probably will not have quite as many. That's because I've done some different stuff. But if we actually look here, this one right here is where we want to look at. And what do we notice about this? Well, we have an IP version 6 address there, and there's our 8 hexadecimal digits, and you'll notice that some of them don't have 4 digits every time. That's because leading zeros can be omitted if we want to. And so like right here we would have 0153. So that's our IP version 6 address for my desktop computer. And then we have the IP version 4 address for my desktop computer, which is right there. All right, and these are the private addresses. This is not what the internet sees. You're not going to be able to find my computer because you've seen this private IP address. This could be on any network. We're going to skip over the subnet mask for now. If you want to learn more about that, you can feel free to look that up on the internet, but it's not really in our scope, so we're just going to skip it. And then we have our default gateway here, and you'll see both an IP version 6 and an IP version 4 address. Here is the default gateway of my router. So if I take that 192.168.0.1 and I was to type it up here, 192.168.0.1, it actually connects me to my router. So I have a router at my house, and it's a TP-Link Archer 8, right? And it would ask me to log in, and I could do all kinds of stuff with that. So I connected straight to my router, and I didn't type in what we typically think of as a .com or .org or .edu address. I just typed in the IP address, and it took me there. So we're going to bring this back up now. Oops, clicked on the wrong thing. There we go. So that's our default gateway. So that is the IP address of our router. Now the rest of this is mostly useless, but that ipconfig command, will allow us to look at that, and it stands for IP configuration, and allows us to see it on a Windows device. And if you use Linux or something, you'd use something called ifconfig, but it does basically the same thing. All right, so I can type CLS to clear that out. Now let's think about some other commands. Let's say that I want to make sure that that router is up. So I want to make sure that it's working. So I can use the ping command. The ping command will allow me to check and see if my router is even responding. And so I could do ping 192.168.0.1. And I'll ping it, and you'll see, all right. So it's sending 32 bytes of data, and it's getting a reply of 32 bytes in less than 1 millisecond. And it just sends 4 whenever I do this, and then it gives me a little response here. So it sent 4 packets of data, it received 4 back, and gives me an approximate time in milliseconds. So it seems like that is up. I could also ping Google's DNS server. So 8.8.8.8. That's Google's DNS server. So it looks like their DNS server is up as well. I could also CLS. I'm going to ping their other DNS server. So there we go. So I'm able to check and see that these are actually up. And you could even just do this. You could say, I want to check and make sure that Google works. So ping www.google.com, and it will automatically resolve that for you. And look at that. That's an IP version 6 address right there. So we're pinging google.com at their IP version 6 address. Same thing. Everything seems to be working. Right? And just for funsies, let's see if we can copy that. It'd be kind of hard sometimes to get all that right. Grab that. So it doesn't like in the address bar, it doesn't like these IP version 6 addresses, especially the way I have it written. Let's see if adding the zeros will make any difference and taking the colon out will make any difference. No. So, doesn't like those IP version 6 addresses, but it does like those IP version 4 addresses. Alright, so we were able to do that. So that's the ping command. Now there's some other interesting commands. Let's say that I wanted to know the actual route, how many steps it took, because there's other devices that my information is traveling through between here and a website, for example. So I could use a command called traceroute. And traceroute is going to try to get as much information as possible about all of the devices between where I am right now and the actual endpoint where we actually end up connecting to. So if I do traceroute and let's say Google's DNS server here, let's see what information it will give me back. And this will usually take a second because it's got to communicate with each thing and get a response back. So here what happened is we connected to my router. So this is my router's private IP address and it connected to my router. And here you see we're connecting to other devices and these are public IPs for other devices. And each one of these steps is where we've sent our traffic, our information to it as we keep going. And see, oop, there we hit another one and hit another one. And these are other addresses that we're getting back. So these are all the devices that my traffic is having to go through to reach this address right here, 8.8.8.8. And this happens very, very fast every time we do it. And of course you can see these are all millisecond values, how long it is taking for them to receive the data and transmit back and everything like that. So now my trace is complete. So it took 9 hops, we call these hops. It took 9 hops, all of these different devices here, to get to Google's DNS server, and it happens so fast, so fast. Like you don't even notice how fast it goes because we're pretty much at the web page by the time we're done typing it and hitting enter. So that's the traceroute command that traces the route of the data as it goes through the different networks. Now maybe I want to look up, I want to do the whole DNS thing. So we talked about the DNS here, the domain name system, how we translate those URLs into IP addresses. And I'm going to show you how to do that with Google here. So we can actually do a command called nslookup. And this is, I want to know the IP addresses that are associated with google.com. So if I do www.google.com, it goes and does a lookup. Now, you'll see that it uses a server. Now, my domain name server is via my ISP. So my ISP, I'm not using Google's domain name server. I'm using my internet service provider's domain name server, which happens to be Wave Rule Connect. And so we have fiber cable there. But here's the answer that you get. So Google is at this IP version 6 address and is at this IP version 4 address. So if I copy that real quick, that IP version 4 address, and I paste it right there, lo and behold, it takes me to Google. So that's what's happening behind the scenes. You don't notice it, but that's what's happening every time you go and try to go to a website is you need that IP address. And it's going and looking it up for you. So we could do an nslookup for just about any website that we want, and we can figure out the IP address of that website in both the IP version 4 and IP version 6. Some more interesting commands. Clear that out. Netstat. So netstat stands for network statistics, and it will allow you to see active connections on your network. And so this is my desktop right here. This is a loopback address. If you paid attention earlier, you'll see that's a loopback address. And then all these little colons you'll see, those can be kind of confusing, but those are what we call ports. We'll talk about ports a little bit later whenever we talk about how to use ports. And then you'll see, all right, so there's a private IP address, private IP address, private IP address. And these are all the foreign addresses that it's actually connecting to and things like that. So I'm not going to wait for it to finish here. Hit Control-C so that it'll stop. And clear that out. But anyway, that's what netstat is for, is it shows all of those active connections. And you have local addresses and the foreign addresses. Now, another very interesting one is, what if I wanted the MAC address? So we talked about MAC addresses, because we have IP addresses, we have MAC addresses. We don't see MAC addresses as often in front of us, but they are there, they are being used. I can do getmac, like this. And you'll see these media disconnected ones you want to ignore, right? And you may not have as many, but one of these is the actual MAC address of my device. So if we assume it's this one right here, you'll see that is 6 hexadecimal numbers, and that is associated with the NIC, or Network Interface Controller, on my device. And you'll see several different ones of these that are identified in different ways. That's because you may have multiple network interface cards, you may have multiple things that have connected to it before, but one of these is the actual MAC, and you use the getmac command for that. Alright, final thing for this video. Some interesting commands to play around with there. You can try all kinds of stuff. The last thing I want to talk about after we do a little lookup here is the OSI model. So last thing I want to show you with these cool commands is, here I have a browser called Brave, and I have something called Tor connected right now. And Tor uses proxies and effectively a VPN and a proxy. And what that does is it is going to hide my IP address. And I'm going to use this website right here to actually look up my IP address, and it's probably going to be somewhere else in the world as opposed to where I actually live. So we have, what's my IP address, find your public IP address. I'm going to copy that link, open Brave back up here, and paste that, and hit enter. So let it run here and give it just a second. So here it's found the IP address that I technically am supposed to be, but it's having a little bit of trouble figuring out where I'm at and what I'm doing. It seems to think that I'm in Texas, which I can most assuredly tell you I am not in Texas. Right? This is the IP address it thinks that I'm at, but that is because I am running through a proxy service. That's what Tor does, is it encrypts the traffic and it works as a proxy, and it sends it through several proxies, and so it thinks that my traffic is coming from Texas, and it's not. Right? So that's what Tor is really good for, is it helps you hide that sort of information if you're trying to get a little bit of privacy, that type of thing. But you'll see there's both an IP version 4 and IP version 6 address, and it will look up your IP address. And you can do this in class. I'm just not going to post this on the internet with my public IP address. That's really bad to do. You shouldn't share that with other people. So exit out of that. This website right here is a really good website. It allows you to look up all kinds of things. It has traceroute tool, ping tool, all kinds of stuff. You don't want to use the command line. It's very useful for that. And this is the website you'll use if you can't use Windows. So if you're on a Chromebook or something like that, you can use this. And Chromebook does have a command line. It's just a lot harder to get to. They don't like to give you access to those types of things. All right, last thing here. Let's talk about something called the OSI model. This is just going to be a brief little discussion about what it is. So if we look here at, let's see if I can get a little bit more room. So the OSI model looks a little bit like this. Let's see if I can fit this to my screen a little bit better. Alright, so the OSI model, which stands for Open Systems Interconnect model, and then we have the TCP IP model. These are basically the same thing. There are obviously differences because you can look at both sides, but it describes what we call the layers of the internet. And then we have some examples of protocols and services that operate at those layers. So the OSI model is the one that is traditionally accepted, but they are both used and discussed quite a bit. But we have the physical and data link layers here. So physical is like the actual cables or signals that are sent through. And then the data link is the actual connection between the devices. So like your connection between your computer and your phone, for example. That would be part of the data link layer. And the TCP IP model sort of lumps in the data link and physical layers because they're very closely related. So Ethernet and Wi-Fi are what are going to go there in that link layer. Then we have what is called the network or internet layer as we look at these, and that's where your IP protocol, what we call ARP, which is Address Resolution Protocol, and ICMP, which is Internet Control Message Protocol. These are protocols that have to do with communications at the network level. So the network being like your router here, your router is the network, and it's communicating with all of these different devices on that network, and it uses the IP, ARP, and ICMP protocols to do that. You'll also see some TCP and UDP thrown in there because that's the transport layer. That's the next one. The transport layer, TCP and UDP, which we haven't talked about, really has to do with how the information is sent over the internet. So, for example, videos are typically sent via UDP, and like web page information is sent with TCP traditionally. And then at the top layer we have the TCP, we have the application part, which is broken down into three pieces, which is session, presentation, and application in the OSI model. And this deals with things like what you actually see at the application. So HTTP is web pages, HTTPS is also web pages, DHCP is that dynamic host configuration protocol that we talked about. Anyway, so on and so forth. This is what you actually think of as like the web page that you see, and that includes like session information. So like you being logged in, okay, you typically have a session associated with you being logged in and accessing that website. And so that's what some of that stuff is. But basically, in general, these models are how we break down the different layers of information that we send through the internet, right? Because as you can see, there's a lot of information going on here with all of the different addresses we have to keep track of. What is your public, what is your private IP address, and that sort of thing. All right, that concludes our introduction into basic networking and things that you can do with this. Remember, if you have any questions or anything like that while you're working on this in class, feel free to ask. And thanks for watching.